So in this video, we're going to take a further look at independent events. And a lot of this you will have covered already in some of the previous videos, but let's just formalize our understanding of this idea. Right, so two events are independent if one event happening does not affect the probability of the other. So if this is the case, then the probability of them both happening is found by multiplication, right? So if we have two events, A and B, then the chances of them both happening, A and B happening, is the probability of A multiplied by the probability of B. Now, we may have seen this before in tree diagrams. We may have seen this before in a number of places, but that is the official thing to remember. And let's see this now in a few examples. So a die is rolled twice. If event A is the first roll, shows a 6, and event B is the second roll, that also shows a 6. Are they independent? Yes, of course they are, because that first roll of the dice does not influence the second roll of the dice, so they are independent. It doesn't change that probability. So, part B, find the probability of A and B both occurring. Well, the probability of event A occurring the first 6 is 1 out of 6, so it's 1 over 6. The probability of B occurring the second roll of a 6 is also, of course, going to be 1 over a 6. So the probability of A and B both happening, it's going to be 1 over 6 multiplied by 1 over 6. Of course, that is 1 over 36. And that is all we have to do. Okay, let's carry on. Let's look at a more complex example now. A spinner in a game has 3 sections of equal size that are colored red, blue, and green. Let the events B, R, and G be, and it says there, of course, that B is the chances of it landing on blue, G is green, and R is red. Are these independent of one another? Okay, so, well, if we spin this once, we cannot have more than one of those outcomes happening. However, they are going to be independent if we think about it spinning multiple times, of course, right? So if it spins and lands on blue on the first spin, well, it isn't going to make any difference to the result on the second spin, okay? So are they independent? Yes, that each spin is independent of the next spin. Okay, B, let's find the probability when a spinner is spun twice of various different outcomes. So, both being red. Now, before we go any further, let's just go back and think, well, of course, it's going to be a third for each of these probabilities. The probability of it being blue, green, and red is each going to be a third. Okay, so the chances of it spinning twice and both being red is going to be a third times a third, right? Well, that is going to be 1 over 9. Now, part 2, red and green in any order. Now, this is a great question, right? Okay, so we've got 2 things to consider here. Now, if we think about red followed by green, well, that is going to be a third times a third, because the chance of being red on the first go is a third. The chance of it being green on the second go is a third. So that's a 9th again. But as well as that, we could be thinking about green followed by red. Well, that would be a third multiplied by a third too, which is also a 9th. So if we know both of those different outcomes, then what is going to be the combined outcome of either one of them happening? Now, when this situation happens, we're going to need to add those together, not multiply, add them, right? So it's going to be a 9th plus a 9th, which is 2 9ths. Okay, in the same way, part 3 is asking us for both being the same color. So this means the combination of 3 different probabilities, right? We need to think about red, red, plus blue, blue, plus the probability of green, green. Now, we've already seen red followed by red is 1 over 9th, and of course, 1 over 9. And of course, blue followed by blue is also going to be a third times a third, which is also 1 over 9. Green followed by green is also, for the same reason, is going to be 1 over 9. So if I want to find the likelihood of both being the same color, I'm going to need to add all 3 of these probabilities together. So this is going to be 3/9, which is, of course, 1 over 3. Right. Moving on, final example now. In a school, 20% of children are colorblind and 10% are left-handed. If a child is selected at random, what are the probabilities that they are neither colorblind nor left-handed or left-handed? Okay, well, being colorblind and being left-handed are independent events. We have to assume that one does not affect the other. So therefore, we can start to multiply when we think about these 2 different events. So if they're not colorblind, well, that is going to, let's write some statements down. So CB is going to stand for colorblind. So the probability of that is going to be 1 over 5, which corresponds to 20%. Not colorblind, therefore, is, of course, 80% or 4/5. All right, that's going to be, our probability, of those 2 events occurring. And then the probability of being left-handed, LH for left-handed, is going to be 1 over 10. So the probability of not being left-handed is, of course, 9 over 10. Okay, now with that out of the way, let's answer the questions. So is not colorblind or left-handed. So we're going to need to work out for A, 4 over 5 multiplied by 9 over 10. So the likelihood they have neither. So 4 times 9 is 36. 5 times 10 is 50. We're going to simplify this down. That's 18 over 25. Let's carry on with part B. So colorblind and left-handed. So that means they have to be colorblind, which is 1 over 5, multiplied by the probability of being left-handed, that's 1 over 10. So this is going to be 1 out of 50, and that can't be simplified. That's our final answer. Now, final part of this question, we've got to work out the probability of being left-handed but not colorblind. So left-handed is 1 out of 10. But not colorblind is 4 out of 5. So we've got to do 1 over 10 multiplied by 4 over 5. This is going to be 4 out of 50, which can be simplified down to 2 out of 25. Okay, so hopefully you've understood that this golden rule for independent events is multiplied. But when we're collecting up different events that could happen, we're going to need to add those. Okay, hopefully you understood this video and hopefully you can answer the question.